welcome to our video. It's formulas and rules for integration, but the first thing we'll be dealing with formulas. Right, so number one, we are saying integrating a constant. So integral of k dx, dx is our integrating variable. This will result in kx plus c. Kx plus c is our antiderivative, which means if you differentiate kx plus c, we must return to k. So that's why we write here reversed antiderivative, which means if I differentiate kx, the result will be k. What about this c? So we are saying differentiating a constant, this will result in plus 0. That's why we are saying integrating k, this will result in kx. Right, so example 1 here is item 1, integral of 5 dx. So this will be equals to 5x plus c. So in terms of constant here, a constant c here, you can write k. You can also write a. There's no problem. Right, then number item 2, integral of half dt. This is equals to half t plus a constant c. Then item 3, integral of root 2 d theta. Our integrand variable is d theta, so this will result in root 2 theta plus a constant c. Then item 4, integral of dx. Right, so integral of dx, this can be written as 1 times dx. So this will result in x plus c. Remember, x is same as 1 times x. Right, so it's integrating a variable. The next thing is integrating a variable. So integral of x to the power n dx is equals to, so we add 1 on the power, so it's going to be x to the power n plus 1 or over n plus 1 plus the constant c. Right, so n should not be equals to minus 1. So we are saying when n equals to minus 1, we are going to have minus 1 plus 1, which is 0. So x to the power 0 will result in 1. But 1 divided by 0 will be an error. So n should not be equals to minus 1. Right, so item 1, we are saying integral of x to the power 2 dx. So this will result in x. Then on power we add 1, so it's 2 plus 1 or over 2 plus 1 plus a constant c. So this will result in x to the power 3 or over 3 plus c. Then item 2, integral of t to the power minus half dt is equals to t to the power minus half plus 1, we add 1 on the power, or over minus 1 half over 2 minus half plus 1. So if we simplify this part, will result in 2 t to the power half plus c. Then item 3, integral of theta to the power minus 2 d theta. This will result in theta, then on power add 1, so it's minus 2 plus 1 or over minus 2 plus 1 plus c, which result in theta to the power minus 1 or over minus 1 plus a constant c, which is equals to minus 1 over theta plus c. Integration of form ax plus b close bracket to the power n. Right, so in this case, ax plus b should be a linear function. So when you're talking about a linear function, we are saying the highest power of that polynomial should be x to the power 1. So our highest power here is x to the power 1. So ax plus b is a linear polynomial, then which is close to the power n. So how do you integrate that this function which is in this form, given that ax plus b is a linear function? So it's integral of ax plus b close bracket to the power n dx. So here we return that linear function ax plus b close bracket to the power n plus 1. So we add the power 1 unit divided by the sum, so it's n plus 1, times the derivative of this linear function, so it's times a. So if we differentiate ax plus b, we're going to have a plus a constant c. Right, so let's go to the first example here. So it's item 1, integral of 2x plus 3 close bracket to the power 3 dx. So 2x plus 3 is a linear polynomial, right? So if you look at this one, it's a linear function, it's a linear function. 2x plus 3 is a linear function, right? So the idea here is to return this linear function. So it's 2x plus 3 is our linear function. Then we add the power 1, add 1 on the power, so it's 3 plus 1 over that sum here. So we write 3 plus 1 times the derivative of this linear function, so this will result in times 2. So we are going to have 2x plus 3 close bracket to the power 4 or over 8 plus a constant c. Right, so let's go to this one, item 2. Integral of root open brackets 2 minus 3 t close brackets the t. Right, so this can be written as 2 minus 3t to the power half. So I'm very sorry here, it was supposed to be dt here. Right, should be equals to. So number 1 is to return this linear function. So I'm going to have 2 minus 3t to the power half plus 1. So I add 1 on the power divided by the sum of that power here. So it's half plus 1 times the derivative of this linear function. So if you differentiate this linear function, we are going to have 0, then differentiating minus 3t is equals to times minus 3 here, plus a constant c. So if you simplify, this will result in 2 minus 3t close bracket here to the power 3 over 2 or over minus 9 over 2. Then finally we have a minus 2 over 9 close brackets 2 minus 3 close bracket